DSMA 5 is about rounding numbers. Now, in life in general, you'll see a lot of numbers that are being rounded. And I know we hope that these numbers are always rounded in our favor, especially when it's in consideration of monetary amount. But what we want to always do is to be fair and follow the rules for rounding so that everyone gets equally treated. Let's take a look at our image here. So I'll call this my little molehill, and that number 5 at the very top of the hill is very, very important. So if a number is 5 or greater, we are going to round up, which means we are going to add 1 to the place value. It'll tell us to round to the nearest place value, and we're going to add 1 to the place value that we're working on. All right. If the number is less than 5, the place value remains the same. So let's take a look at the formal rules on the next page. All right, rounding numbers, basic rules. Number 1, if the number to the right of the rounding number is 5 or more, then the left rounding number, the left, which is the rounding number, goes up by 1, just as we said earlier. 5 or larger, round up by 1. Step 2, if the number to the right of the rounding number is 4 or less, let's emphasize that, 4 or less, so any of those numbers, then the rounding number remains the same. So again, 5 or more, so 5, 6, 7, 8, or 9, we add 1 to the rounding number. If it is 0, 1, 2, 3, 4, then we will remain the same on that rounding number. Step number 3 says every number after the rounding number becomes a 0. Every number after the rounding number becomes a 0. And it says everything before the rounding number remains the same. So we basically are focusing on that rounding number or that place value that we're rounding. And it says if the rounding number is a 9 and it goes up by 1, so obviously if you have a 9 and you have to increase it by 1, then a 0 is going to be placed in the rounding number, and 1 is moved to the next place to the left of the rounding number. It's kind of like when you do your adding, you're going to carry that 1 over to the next place value to the left. The most important part about rounding numbers is that you need to understand the place value that you're working with. So let's take a look at our place values. You can see at the very top here, let me write a little arrow. This is my decimal. So what's in front of the decimal is considered a whole number. All right, and our place values are going to be 1, this is our ones, tens, hundreds, thousands, 10,000s, 100,000s. Now, normally there's a little hyphen in between the 10,000s and the 100,000s, but I've seen it printed both ways. As we extend further to the left, we get into the millions, 10 millions, 100 millions. Again, sometimes hyphenated and sometimes not. All right, and then what you want to take a look at is billions, 10 billions, 100 billions. So you can imagine if we continue to stretch to the left, the next one would be trillions, 10 trillions, 100 trillions. All right, so each one of these, notice at the top, has what we call a period. Let me see if I can highlight this. This first 3 numbers are in the ones period. The next set is in the thousands period, millions, and then billions, and as I did earlier, would be trillions. All right, the way you say your decimal would be and. If we had to write this into words, the decimal would be and. And then once you go to the right of the decimal, you are now working in decimal form. So notice in decimal form, they're adding in a THS on the very end of each of the titles. So we are actually starting with the tenths position. There's no such thing as a once position. There's a tenths position, hundredths, thousands, 10,000s, 100,000s, and then millions. And then from the millions, we can keep going to 10 millions, 100 millions, and then billions. All right, so it's real important. Make sure you review this chart and know your place value. When we say round to the nearest hundredths, you need to be able to locate that position so that we can do the correct rounding. Write the decimal number in words. So here is our original number, and the way you would say this in words is just go left to right. There is a little decimal right here in case you can't see it. So the first thing is a negative sign. We would say negative. And the next thing you want to do with this number is you want to take a look at the numbers that follow your decimal. Since there is no whole number, there's a 0 there, we're going to focus on the numbers after that. So this number is a 308, and the way you would say 308 is if it were a whole number. So this is 308. And then when a number's to the right, you want to grab the very last number and find out what is the place value. The 8. The place value for the 8 is going to be the thousandths. Remember, that's a THS, thousandths. If it's to the right of the decimal, everything follows with the THS. So then we're going to go through this and match the correct answer. And let's see, negative 308 thousandths. And that looks like the first number is our correct answer. Option A. All right. Then it says down at the bottom, round the decimal, the very same number we're working with, to the hundredths place. So let's think about our position. The hundredths is exactly where the 0 is. So we want to know if this 0 increases by 1 or if it stays the same. So we look at the number to the right, and we know that 8 is greater than or equal to 5, right? So yes. So that means I need to add a 1 to that place value. All right, and when I add a 1 to that place value, my rounded number, I still keep the negative sign. I now have a 3 and a 1, a negative 31 hundredths. So the answer on here is negative 31 hundredths. So here's what you need to remember about rounding decimals. If it tells you to round to the hundredths position, there should not be anything after the hundredths position when you are done. So there should be no values after the rounded place value. All right, so negative 31 hundredths would be the correct rounded number. Insert less than, greater than, or equal to between the pair of numbers to form a true statement. So let's go over our inequality symbols. This one means is less than. Is greater than. And this one is equal to. So remember, the crocodile mouth opens to the larger number, or you can think of these as pointing. The little arrow end, the point part, is towards the smaller number. So when we are comparing numbers, what we can do is to rewrite this. I have 45 hundredths. Remember, I'm going to try to say that properly for us. And then I have 41 hundredths. So since what's before the decimal is a 0, we won't compare that, but we will first go in and compare the next digit after. So they both have a 4, so they're still considered equal. Now we're going to go in and look at the 5 and the 1. And let's compare the 5 and the 1. So 5, 1, we know that 5 is greater than 1. So in this case here, since 5 is greater than 1, the original numbers to the left, the 4500ths, would be greater than. So what you do is you move to the right of the decimal until you find a place value where the numbers differ, and then you compare those numbers. Again, this works when they're both positive. All right, this only works when they're both positive values. Once again, we will insert less than, greater than, or equal to between the pair of numbers to form a true statement. All right, so let's take a look at these numbers. I have a negative, a 0.34, and I am comparing it to a negative 0.31. Okay, we will start this one just like we did the last one. In front of the decimal, they both have negative signs and they both have a 0. After the decimal, we're going to start with the 10ths position and move to the right until we have numbers that do not match. So in the 10ths position, they both have the 3. So it's the same at this point. Then when you get to the 100th position, we notice that they have a different digit. So what we're doing at this time is we're going to compare the 4 to the 1 as if it were positive. And as if they were positive, 4 obviously is greater than 1. Remember, we point to the smaller or crocodile mouth open to the larger number. All right, now the fact is that they're really not positive. They're both negative. So we'll add those negative signs in. When they're both negative, what you do is reverse your sign. Negative 4 is less than negative 1. So the answer for this would be negative 3400ths is less than negative 3100ths. All right, and some of us sometimes need to see that. So if we had a number line, I can place 0 here, negative 1, oops, negative 2, not quite equally spaced. But we can see that this negative 4 here is smaller than the negative 1. Number to the left is smaller. The number to the right will always be larger. So negative 4 is less than negative 1 is correct at this point. All right, another problem where we're inserting less than, greater than, or equal to in between these two numbers. So if I write these numbers out, I have a 0, 3, 6, 1, 0, 0, and I'm going to compare it to decimal 361. All right, so once again, you can see in front of the decimal is a 0 for both numbers, so they're the same. In the 10th position, they both have the 3, they both have the 6, and they both have the 1. Once we get to the 10,000ths position, remember this is tens, hundreds, thousands, 10,000ths position. There's a 0 there, but we don't have anything over here. So when there's nothing listed, it's the same as having a 0. So what's happening here is these numbers are equivalent. So we would never write a number like this on my math lab, or if on a test, or when you're actually going to translate this into words, you would rewrite this as 361 thousandths. You would leave those zeros off, which would make that equivalent to the second number, 361 thousandths. All right, so we will place that equal sign here, and we would move on to the next problem. Round to the nearest 10. All right, it didn't say tenths with the THS, it just said 10 to the nearest 10. So be very careful about what you're reading. We're going to go find the tens position. Let me rewrite this. We have 36,917 and 816 76 thousandths. That's how we would say that number, and that is exactly how we would write it into words. We are looking for the tens position. So the 1 is in the tens position here, which means we need to look to the right of 1 and ask yourself, is 7 greater than or equal to 5? And the answer for this is yes. And since it is a yes, we are going to add a 1 to that tens position. And then basically going to just add here. We'll write from left to right. So this becomes a 3, 6, 1,000, 9. And then the tens position, now I have 1 plus 1 now, which makes it a 2. Remember, any number after that rounded position becomes a 0. And there's no sense for us to put a decimal with 3 zeros behind it, so we leave it as is. So this value here is the rounded value that I would place here. 36,920 is rounded to the nearest tens. Round the following number to the nearest thousandths. So I'm going to rewrite this. And something that I haven't mentioned just yet is this lead 0 in front of the decimal. And I call it a lead 0. So if you are working in the medical field or you see a physician writing down some medication, you may see them write something like this down. And what happens is, since it has a 0 out front, we automatically know when you're working in a hospital setting that there is an understood decimal right there, regardless if they placed one or not. So it's really important, especially, if you're doing medication and measurements or measuring how much weight you want to put on a scale for maybe some orthopedic rehabilitation. The decimal matters. Okay, let me see. What I'll do right now is let me go ahead and remove that, and we'll focus on our rounding. So this one says round to the nearest thousandths position. So we need to go find that thousandths position. You have tenths, hundredths, thousandths, right there where that 3 is at. So we want to know, does it stay a 3 or does it increase to a 4? The number to the right of it will let us know. So once again, we ask, is 2 greater than or equal to 5? The answer in this case is no. And since it is a no, this 3 remains as is, and we just drop off the number 2. So the rounded number is going to be 613 thousandths. And this would be the final answer. Let's try that one more time and take the same number and let's round it to the nearest hundredths. All right, so I'm just going to insert that in there. Let's round to the nearest hundredths. All right, same number. And once again, we're going to take a look at the hundredths position, which has the number 1 in it. And we look to the right of that rounding place value. So is 3 greater than or equal to 5? And once again, our answer is no. So what happens is both of the numbers after the hundredths position will be dropped off, and the number in the hundredths position stays the same. So this becomes 61 hundredths. And this would be the rounded number. We are going to take this next number and we are going to round it to the nearest thousandths. So let me just do a quick rewrite. Goodness, that's a long number. All right, I think I have it all there. There we go. And we're going to round to the nearest thousandths. So we need to find the thousandths position. So remember, this is tens, hundreds, thousands. Right, so the number 5 is in the thousandths position. To figure out whether 5 remains 5 or it increases to a 6, we must look to the right. Question: is 2 greater than or equal to 5? I bet you have my answer. The answer is no. So therefore, all the numbers behind the rounding number will drop off. And what we have is 5 and 135 thousandths. And this would be our final answer. All right, let's say I take that number again, but I want you to round to the nearest 100 thousandths. Leave my, self enough room. 100 thousandths. All right, so 100 thousandths. So again, I'm going to take this number. I have 5.13, 5, 2, 3, 9, 6, 1. And let's go find that 100,000th position. All right, so starting with the number after the decimal, this is my tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So the 3 is my 100 thousandths position. We're going to look to the right to see if I remain a 3 or increase by 1. So is 9 greater than or equal to 5? That's the question you have to ask yourself. And the answer, of course, is yes, 9 is greater than or equal to 5. So that means I need to add 1 to that place value. So everything in front of the place value will stay the same. So this is a 5.135. And in that place value, 3 plus 1 makes this a 4. So remember, everything after on the right-hand side of a decimal will drop off. All right, so we will say this crazy number as 5, and now you're going to say what's after it just the way you see it. 13,524 100 thousandths. Can you imagine what a number? 5 and 13,524 100 thousandths. Impressive. Round the monetary amount to the nearest dollar. To the nearest dollar. We like money, money, don't we? All right, so this one here has a dollar symbol. And we have 4.1.74. Rounding to the nearest dollar, or sometimes they say round to the nearest whole dollar, is going to be the ones position. So the rounding rule is once you find your rounding place value, you need to look to the right and ask yourself that question. Is 7 greater than or equal to 5? And the answer, yes, it is. So that means I will add a 1 to the place value. Whoops. Get that fixed a little bit. There we go. And then we're going to do our rewrite. So this becomes 42. And what follows afterwards drops away. So this is $42 is the number rounded to the nearest dollar. For this next problem, it's asking us to round to the nearest cent. So what you need to know about money is when you're rounding to the nearest cent, you are rounding to the nearest hundredths position. So to the nearest cent is the hundredths position. Right, we're looking to the right of that hundredths position. Is 2 greater than or equal to 5? The answer is no. So therefore the number stays the same and the values after will drop off. So this becomes 45 cents. And this will be your final answer that you would insert into this box. Now, just for writing purposes, something that you may want to start learning is that if you have a number and you are rounding it, so in the beginning, this is my exact number, but once you have rounded it, we use these double tilde bars, which means approximately, and then we give the rounded number. Instead of putting an equal sign, it is rounded. All right, so sometimes we use the little double tildes to indicate that the number after it has been rounded or it is an estimate. A planet makes a complete orbit around a star every 225 and 774 thousandths days. Round this figure to the nearest whole day. All right, so we're going to take this value, decimal, and 774. And if we're looking for the nearest whole day, just like the nearest dollar or the nearest whole dollar, we would look at the ones position. We want to know if that remains a 5 or increases. We look to the right of that number to let us know yes or no. Is 7 greater than or equal to 5? The answer is yes. We know it is greater. So that will add a 1 to the ones place value. And then I add my 2, and my 5 plus 1 will give me 6. And everything to the right will drop off. So now we have 226 days. Right? So that is a rounded number, and we would place it in for our answer. So remember, that is an approximation.